In this video, I'll show you how a good problem description actually solved our whole problem. So it might be cheating the normal problem solving steps a bit, but this can really happen. Hello, I'm Tom. Welcome to my channel where we talk about continuous improvement in an industrial setting. And in this video, we'll go over the problem solving model a bit and specifically step 2, which is make a very good problem description. I'll set the scene a bit. This was in a food factory. As you might know, I'm working mostly in the food industry, and this was about the intake water. So we use water for all kinds of processes, but it comes into contact with food, so it has to be, of course, quality water. We get it from the municipal water supply. It should be good, but we also have some tests, some analysis that need to be done to check that it really is of proper quality. And one of those things is that in your intake water, so before you get it into the storage tank of your factory, it needs to have a bacterial count of less than 100 colony forming units per milliliter. This is a bit of a technical thing, but this is the measure of how many bacteria are in the water. And less than 100, just for those not too familiar with bacteria, is almost nothing. It really, when you are speaking about there are bacteria in a product or in water, we are talking about millions. So this is already a very low amount, and it's more like a check. So less than 100 is almost equal to nothing. Now, what we were seeing is that from time to time, there would be a small spike. So we would have a couple hundred or even 1,000 bacteria in one analysis, and then it usually went away. But still, I mean, this is not good. We were getting it in. Now, there was this filter system when we got in the water before it went into the tank. So what did we do already? As soon as we had one of those over 100 bacteria colonies in our analysis, we would change out the water filters, clean the system completely. So we were spending quite a bit of effort on a problem that, even our quality technologists said, it's not even that scary because they are very individual analyses, but then again, we need to know that we have good water. So when we test also later in the water system, we hardly ever got such high values. So there is some dilution going on. The problem seems to go away, but we of course cannot take any risk with a food product. So we started a problem solving team on this problem, and the first thing we did was to really describe the problem very minutely. So we took the 5 W's to H, so the what and when do we see it and how do we see it and how much do we see, and we combined it also with a good what do we see and what don't we see. So it is not on each of those 7 categories. And there were things like we see a specific coliform bacteria, we see it from time to time, we do not see any trending, but we also started to check and what problem do we actually see. So it's not just that we see bacteria, but what is the rule and what is the rule that the water company has. And we really dug into what do we see in the rules and in how we check these problems. So we had people from the laboratory, we had people from our central support departments. We also called the water company, checked with their experts, how do we actually check water quality? And what we noticed was it doesn't always have to be less than 100. As I said, this is very low. It should be, on average, less than 100. And not just a normal average, no, a geometric average, which is a method used quite a lot in microbacterial calculations. This will basically allow for having one high measure at a certain point, as long as the rest is okay. So it basically says within microbiology, if you have one very high measure, don't worry about it too much. And then you always need the time. 6 months geometric average. As soon as we knew this, we did the calculation. We hadn't been over this limit already for years. So when we were doing our weekly tests, and from time to time, and this is once every couple of months, one of the values would shoot over, this was actually not a problem at all. And that's why I said at the beginning, it may feel a bit like we were cheating the problem solving, but I guarantee you, you will have some problems in your factory that people really assume are serious problems, and they act on it. We also acted on this. We increased our changing frequencies. Those filters that you put in the water pipes, they are not cheap. And of course also the labor that goes into it, and the attention, the extra analyses. We were saving several thousands of euros just by doing, each year, just by doing this analysis and showing that we could reduce all those countermeasures, because we actually had a very safe system. So we were not solving the physical problem of sometimes there being a high count. We were solving our information problem in that we had mistakenly put a much stricter and actually very unrealistically strict process in place to solve problems that did not exist. That too can be a problem. And because we did our problem solving step by step and took the time to really describe the problem, we didn't have to put extra time into a lot of analyses. We didn't jump to conclusions and implemented all kinds of countermeasures that were not going to be useful anyway, but would cost extra money. So this, I think, really proves the steps in your problem-solving model. Really go through them step by step and be critical. Because at first, when we checked the numbers, we saw that indeed, also over the last year, we had a number of spikes over 100. So the problem was still there. And it was not until we really started to dig into, but where are the rules, which rules, how often, and how does this whole water quality control system work, and how are the statistics aligned to check that you have and to assure that you have good water quality, that we find out there was no problem to begin with. Now, I also noticed I wrote 5H2W. This is, of course, the other way around. Now, I hope that this sort of cheating problem-solving team, this nice problem description solving the whole problem, has inspired you to also really go deep when you are describing your problem, and to make sure that you know what you are tackling and also what the real problem of the problem owner and for your organization is. Now, if you like this video, don't forget to hit that like button, subscribe to my channel if you haven't done so already. I'll bring out weekly videos with some examples, with nice information and inspiration on how to use Lean Six Sigma tools in an industrial practice. And for now, I wish you the best of luck in your problem-solving efforts, and as always, enjoy the improvement journey.